Hey, so this video is going to be, it's going to show you how you can write a port scanner yourself um, on your Linux system. It's going to be just a basic TCP connect style port scanner, very simple. And the goal isn't really to, reinvent the wheel or, write your own nmap, although you can do that down the line. But it's more to show you, I mean, if you want to be a hacker, and I don't claim to be a hacker, but if your interest lies in computer security and computer hacking and you know network reconnaissance and all that kind of stuff, then it's good to understand kind of at a lower level like what the code is doing and the tools that you use. Like nmap. Um, Obviously, nmap's been developed for the past I don't know 15 years, 10, 15 years. So we're never going to duplicate that kind of functionality in a 30-minute video. Um, but at least you can see the very basic of a port scanner, how it works, what goes on, the code required, and it's also kind of useful in that maybe you find yourself doing some kind of penetration test, or you're inside some network, and you have no access to the outside world, to the internet, but you want to scan some internal hosts. So you quickly write up your own port scanner. So there is some kind of practical use to it as well. Things to note though is, like I say, this kind of port scanner is very detectable, very slow. It's one of the most basic port scans you can do, and it's probably one of the first kind of port scan technology that was available. And nowadays, I mean, there's a whole bunch of different kind of stealthier, faster ways to scan a host. But for today, we'll start simple. Build a port scanner with C on your Linux system, and I'll show you line by line. Alright, so first I'll create portscan.c, and I'm just going to include all the relevant libraries, and I'll explain them in a second here. Go like this. I think this. Think that. I'll probably need this and this. So the first three header files are related to our network functions we're going to use, the networking API. And I'll show you this function in a bit, but I mean basically you need these. This is where your functions are declared for the networking kind of function we're going to use, like connecting and creating sockets. This is standard input-output for printing to the screen, and string.h because I'm going to need a certain string function, which I'll explain to you in a second. So like all C functions, we start with our main, or all C programs start with our main function, and make sure that we collect our argument variables. So what this is every C program, the entry point is main. So whenever we execute our program, it's going to pass in the first argument will be the number of arguments on the command line. The second one will be a list of strings which point to each argument passed in. Okay, so first variable I'll need is a structure, sock address, internet, and we'll call it remote for remote host. I'll explain this a little more in detail later, but for now what you need to know is this is kind of the default internet structure, and what this is, it has members that we're going to use to we're going to fill out, and it'll correspond to our remote host. So there's a member called port, there's one called address, so that our port and our IP address will be in there, as well as like the family type, which is internet type. We also need a socket file descriptor to work with, so we can read and write data to it and open it. So for that, it's actually an integer. We'll call it socket file descriptor, SFD. And so this is the socket call, and I'll show you it in a second. Let's look at the socket call real quick. So int socket, int domain. Domain is going to be almost always AF inet or inet 6 if you're using IP version 6. So that's internet protocols. You can see all the other protocols. You're like never going to use those, with the exception of maybe Unix protocol. Almost always you'll be working with IP version 4 on the internet or 6. Most of these are kind of older protocols they don't really use anymore. Now, same thing with the type. I use sock stream. Provides a sequence reliable two-way connection based byte stream. So that's TCP. It's reliable communication, layer 4. And then sometimes you might actually use UDP, which is sock dgram, which is connectionless unreliable. But in this case, we're using a TCP connect to check for any kind of open TCP ports. And finally, the protocol is always 0 because it specifies a particular protocol to be used with the socket, but normally only a single protocol exists to support a particular socket type. So the type, it's always going to have one protocol, so you just put a 0, and it'll default to the correct protocol. Now let me show you the members of the structure. So remember this structure here. It's going to have certain members. Now, the best way to find out those members is to actually check the header file. I mean, I say best way. It's probably easier to just Google it, and you can see someone probably give an explanation online, which is better and more clear for you. But if you want to be a Linux hacker or whatever, it's best to use the source. Use your system, learn how to read source. So what we'll do is we'll find what the members are called. So I'm going to do something like grep. Like that. So all I did was grep for basically kind of a definition of our structure that we're looking for. And you can see right here, there's a definition of it here, Linux in.h. You can see this is kind of the declaration of where it is. So we can probably see the members in there. So let's go. And now we'll just search for it in here. And there it is. So this is actually a kernel header file. So we're going to have some different kind of type defs here. But so you see here, SYN family, SYN port, SYN address, and padding. So SYN family is basically the type. It's going to be almost always AFINet. That's internet type. BE16. So again, this is probably a single byte character. This is BE16 is probably a short 16 bits, 2 bytes. Now you can find the actual declarations. These are probably type defs somewhere inside the kernel. But I just know by experience this is a 2 byte short integer. This I'm not sure. I'm pretty sure it's a char, but and then finally there's another structure inside the structure, an in address structure that contains the address. So address family, port number, internet address. Now, and the final one is padding. Basically, because, well, I'll explain that in a second. But padding is, they've got to make the structures all equal. What it is when dealing with socket address structures, there's a little bit of black magic going on in the code. I say black magic. It's just a way for C to kind of handle polymorphism, because most of the networking API functions you use are going to want an actual struct sock address. So there's no _in. This is kind of the default type. But then to get more specific, you have sock address in, which is internet. You've also got stuff like sock address un, which is Unix, and a bunch of other ones. But in order to facilitate or better design the functions that they handle the networking API, they will want the generic struct sock address, but you will pass in a specific one and then just cast it to the generic one. Again, this is done to facilitate polymorphism and make the code cleaner in the API. You can find more information with that online, a much better explanation, I'm sure, than I've given you here. If you're really interested, just Google something like sock address in, sock address polymorphism, and it'll probably get a better explanation as why. But you're going to see what we do here in a second with that, and you'll see kind of the difference and why I'm trying to explain it ahead of time. So now we got that. What we're going to do is, first thing we're going to do is that last member that I showed you, the structure, the padding, we got to make sure it's all zeros. So I'm going to actually just zero out my structure. Oops. So all it's doing is filling out this structure in memory with zeros. And that's just basically to handle the padding at the end. And make sure there's no garbage in there. So now we'll actually fill out the rest of the members. So now the members that we saw, remember, remote.syn port we saw, this takes a port, so let's say port 80. Now you can't just do that. You can't just say set the port to 80. That would be nice. That's the easy thing to do. But a little bit more user friendly would be to take it from the command line. So let's do something like equals argv2. So whenever we run our program, we'll go like /port scan 127.0.0.1 port 80, you know. So it will take the second argument, which is going to be the 80. This is a 0 argument port scan. This is 1. This is 2. But again, that is a character array. So we got to convert that to an integer, and for that we're going to use AC to integer, part of the C standard library. So that will now convert argv2, which is going to be a character array, into an integer. So you know, on the command line it looks like this, an actual string, and AC to integer converts to an actual number. Now again, this still isn't going to be sufficient, because whenever you are writing network programs and you're transferring data over the internet, especially numbers, it's got to be in a certain what they call byte order. When you're on your host, your own system, it's called host byte order. But you need to convert host byte order to network byte order when you're transferring over the network. So there's a function called host to network short h tons, and that takes an integer, which we'll get from a AC to integer, and that will convert that from host byte order to network byte order. Now I'll try to briefly explain the reasoning behind this, but this is something else you should Google for more information. But the reason why we convert from host to network byte order is because you have little endian machines and big endian machines. What that means is little endian machines, I could be wrong which is which, but little endian will store the least significant bit first, whereas big endian will store the most significant bit first. As an example, the number 8 translates in binary to that on a little endian machine. But on a big endian machine, what you're going to see in memory is this. It's reversed. So the reason why we convert to network byte order is that once it gets to the other computer, the remote computer, regardless if it's in a little endian or big endian, and regardless if we have a little endian or big endian, it basically that network byte order is something exclusive that they can both agree on, and then it'll convert that number on its own machine to host byte order. That may not have been very clear, but again, that's something you guys will have to Google. It's a little bit out of the scope of this tutorial. It's not something needed. It's just something that you should delve further into to understand exactly what host to network short does. Now we will also actually, before that, right up here we're going to actually put the family. So remember, syn family. Same thing as the socket, you know, we're going to use AFINet. It's an internet connection, so it's always going to be AFINet. And finally, the address, we're going to use something called inet AC to network. And we're going to use the first argument, which is our IP address, and we're going to shove it into remote.syn address. Remember that remote.syn address, that member was a structure itself of type struct in ADER. Now let me show you the man page for that inet AC to network. So here it is. So it takes a character pointer. So that's going to be our argv1, our IP address, and then it takes the address of a structure just to shove it into. So inet AC network converts the internet host address from IP version 4 numbers and dots notation, so 124.1.1.1, you know, 127, into binary form in, very important, as we went over, in network byte order. So again, we've got to make sure we convert this number, any kind of binary data, to network byte order, so when we transfer it over the network, and that receiving machine, whether it's little endian or big endian, it doesn't matter, and it will convert properly, and stores it in the structure that IMP points to. All right. Now also take notice here. inet AC to network returns non-zero if the address is valid, 0 if it's not valid. So what we'll do is something like this. If so, all this is saying is if this returns something greater than 0, then continue. Actually, what we'll do, we'll check for 0. It's probably going to be better. So all that is, that's just a Boolean check. So it's saying if not. So if it is 0, it'll test as true, because 0 is not, it's 0. Where if it's anything other than 0, that will fail the check. And so if it's 0, we're going to say error and return -1. So if this fails to convert our IP address, it'll error out and return -1. We should also check the return value up here. And I know that if it returns less than 0 here, it is an error. Again, we'll call p error on socket. Return -1. Now, again, if you're not sure what the return value should be, I'll use the man page. So we'll just check out socket and tell you here. So it returns an integer. And to see what the return value should be, there's always return value section in the man page. On success, a file descriptor for the new socket is returned. On error, -1 is returned. So if it's a -1, less than, which we're checking for for less than 0, we know it's an error. The way that works is file descriptors are integers, and the first 3 are reserved: 0, 1, 2, 3. Or sorry, 0, 1, 2. 0 is standard input, 1 is standard output, 2 is standard error, I believe. So let's go back. So again, if this returns less than 0, we know there was some kind of issue creating a socket. Maybe the system has no resources or something. Maybe you have no privilege somehow. Who knows? But we check for less than 0. Usually it's always going to pass, but good to check. Then we come down here. We zero out our structure. Then we set the family AFINet because it's an internet socket connection we're making, and the port. And now remember, it's very important. We convert from host byte order, which is our system, to network byte order because it's being sent over the internet. And then, we're taking the second command line, but again, it is a character array, so we've got to convert that with AC to integer to an integer. Then we're calling inet AC to network on the first argument, which is going to be our IP address, and stuffing it inside of our structure. Remember again, remote.syn_address, that member of that structure is also a structure. So we're shoving that binary data, which is going to be our IP address. It's going to convert to binary network byte order address and shove it into that structure. We then check, as we've seen by the main page, this function returns 0 on error. So if it's 0, again, we're doing a Boolean check. If not, so if it is 0, we error out and return -1. So if we get to this point, whoops, if we're at this point here, it means essentially we can go ahead and make the connection. So now what we'll do is I'll assign a return value here, and then so connect. I'll show you how we call it, and then we'll check out the man page. The first argument is the socket file descriptor, which we have opened. So you need to open socket file descriptor. What that is you'll use that socket file descriptor in calls to like read, write, connect. Obviously, will establish it, and then to read and write back to that network resource, so to the server, you'll need to use that socket. So we're going to open that socket with this following address, which will be, I'll explain this in a second. Now the second one wants the actual sock address that we're going to connect to. Now connect, because of that polymorphism I spoke of earlier, which I know is kind of confusing, especially if you're new to C, and you have to look that up. But it expects a struct sock address, not a struct sock address _ internet. So what we got to do is we got to cast that internet socket address into the generic sock address structure. And then finally it takes the size of the structure that we're passing in, which we can just do something like this. And then the return value, well, let's check the man page now, see what the return value should be, which I believe is greater than 0. So connect, as we went through, the first argument is the socket file descriptor, which we created with socket. The second one is a sock address, pointer, which we create a sock address internet, and so we got to cast it to the sock address type. And finally, it's the address length. And again, you can see here, something that'd be confusing if you're new to C is this is not an actual C data type. It's some kind of type definition. So again, you can use a source. You can go check. It's most surely going to be in one of these header files. This one, or maybe this one. Probably this one. And it's probably going to be type def into 32 bits. So a long integer. But again, check it out. It's going to be different with a 64-bit call and what have you. But I know that it's 32 bits, 4-byte long integer. So then we say, let's just read it here quick. The connect system call connects the socket referred to by the file descriptor to the address specified by address. Return value. If the connection or binding succeeds, 0 is returned. So this one, on success, will return 0. On error, -1 is returned. So we'll do something like this. If return less than 0, error out, and return -1. Otherwise, the port is open. And real quickly, I haven't explained this. P error. Let's look at the man page. But all it is a way of reporting error functions or error information to you. It uses something called error no. But let me just show you. P error function produces a message on standard error describing the last error encountered during call to a system or library function. So, the last call we have here is connect. So if that does error out, we know it'll give us the information based on why that error happened. Same thing here, this will be the last function call, library call, and so if there's an error, we'll get the information pertaining to that. And all I do is I just append or prepend the name of the function we're at, and let the system give me the error message. So let's try it out. Let's see if it works. It may not compile. I might have missed something, but let's check it out. Oh, I did. Implicit declaration function in toy. So when you see this, what that means essentially is, implicit declaration is you've forgotten to put the header file in. So what is the header file for a toy? Standard lib, standard library. Thought I put that in, I didn't. So we're going to include the standard library. We had another error too. Error res undeclared. So we didn't actually declare our variable. Oh, I called it return. So let's clear this, compile it again, so it works. And just in case you don't know, you can see here, I'm actually just compiling with no output file. You can actually, call it whatever you want. Oops. Make sure you write the file name correctly. But when you do with no output, if we actually don't define output file, it will by default compile to a.out. Doesn't matter, they're both the same. So now we'll test it out. I have a web server on pinkstyle.org. We're going to need the actual IP address, so I'm just going to dig it. Dig for the A record. Dig is just a way to query a name server, and what I wanted was the A record, so I can get the IP address, which is here. And now we'll run our scanner and port 80. So actually, let's try and fail one first. So I know that port 809 isn't open, shouldn't be. So let's try that first. And so you see during the connect call it says connection refused. So that port's closed. Let's try port 80, my web server, which it is running, should be open. And there you see it says port open. We should probably put a new line to separate that so it's a little more readable. Let's do that. And let's run it again. I didn't compile the right one. Oh, okay. So yeah, let me just clear it, and there you go. So it runs it. My web server, port 80, port open. And then we go to let's say FTP, which I don't think I've opened. Connection refused. 210 connection refused. But then if you go something like I have SSH open, I think it's on a standard port, which probably shouldn't run on a standard port, but whatever. Port open. So you can see, based on that, I mean, we know the services running on port 80 is usually a web server, and on 22 is usually SSH. So this is how you would do like network reconnaissance, I guess in the older days. I mean, even now it still works, but you know what I mean? Very basic. And you can see which ports are open. So from there, what you might do is you might try and check out the banners of those services, find out what version they're running if you can, see if there's any kind of known exploits. If you know that SSH is running, maybe you try and brute force the login. If you know web server is running, you connect the web server, look for kind of exploitable web services. So I mean that's what it is. It's part of network reconnaissance. See what ports are open. Let's modify it a little bit though, because having to dig for the IP address isn't really intuitive. So what I'll do is let's make version 2 of this. Call it portscan2.c. Whoop, not v. .c. And then what we'll do now is I'm just gonna add DNS so that it'll actually resolve our host name. So for that I need another header file, which I believe it's netdb. Include netdb. I'm pretty sure, yes, netdb. That actually will hold the declaration for get host by name. Let me show you here. So what we're going to do is we need another structure here. Oops. And I'll explain this and show you more when we check out the man pages. But essentially we need a pointer to a host entry structure. And we're going to go down here. And I'm going to remove this because I'm not going to use the IP address anymore. So let's go h equal get host by name, and it's going to be the first argument, and then we're going to have to check, I believe it's null. I'm going to have to check the man page here. So get host by name, let's come down here. So get host by name functions are obsolete. I know that. Should use get ADR info. All right, well we're gonna use get host by name. I guess we should be using this nowadays. It's been a while since I did any kind of network programming, but it should still work fine. The get host by name function returns a structure of type host entry for the given host name. Here name is either host name or IPv4 address and standard dot notation. Ask for INET, blah, blah, blah. So essentially we can give it a host name and it'll give us, and it returns a structure down here which contains the actual IP address. That's what we want. Basically it's programmatically doing an NS lookup or a dig or what have you. And does it say the return value? So get host by name and get host by address function return the host entry structure or a null pointer. Okay. So we'll do something like this. If equals null, same process. Whoops. Oh my gosh. So we know if it returns null, it's some kind of error. And so what we do is we do what we've done all along is send out an error message and return -1 to indicate an error. So now what we'll do is we will set that address. So we're going to go remote. Remote dot syn address dot, I believe it's s address actually no, sorry, I'm sorry. Remote.syn address, I believe, yeah, is going to be equal to, and then we need to do what it's pointing at. I'll explain this in a second here. I'm just trying to remember what the actual data field is, which I believe it's this. Yeah. So what we're doing is, let me show you the main page again. This is a little complicated. Where is it? So here's a structure. So this is actually, we're interested in H address list, but somewhere it'll tell us here, where is it? Yeah, H underscore address, the first address in H address list for backward compatibility. So this is like this H underscore address will point to the very first address in this list, which is the IP address we want. I know that doesn't make much sense, but what this is basically a pointer to a bunch of arrays with all the addresses in. So what you'll see is, like, because there can be multiple IP addresses pointing to the same domain name, and what we want is the very first one. So we're going to actually get what that first pointer points to, which is why we dereference it. So which is here, star, and we're casting it to an unsigned long, and then going out and getting so we're going to get the address it's pointed to, getting what's at that address, and casting it to an unsigned long. Again, hopefully that makes sense. I mean, I know it's a little kind of hairy, especially if you're new to C. You know, I'm no expert, obviously, but that should work, and we're going to try it out here in a second. Because now we should be able to actually use the host name instead of an IP address, which obviously is much more intuitive. I don't know if this is going to compile or not. Let's hope it does. Let's check it out. Oh, I see. Yeah, okay, whoops. What is the... so I'm trying to assign to a structure. I actually want to assign into the actual member of that structure. And gosh, I know that doesn't sound very good. Or, you know, it's hard to make heads or tails out of that. I'm not sure if this is even the member. This may not work either. It does. Okay, so let me just show you again what I did here. And again, you guys knew to see, you know, I apologize. I wish I could take more time to explain this better to you. But remember, so our structure, sock address, internet, inside that there's another structure. Let me write it out for you. There's another structure called struct in ADDR. So that's what that SYN underscore address is. The type is a structure of in address. And then inside that structure, there's an unsigned long, which is the actual IP address, which we're converting here and putting it in there, or making it equal to. So I know that's a little kind of hairy, but you know, as you get more involved in C, you'll understand it probably better than I do. But that should work, I believe. So let's check it out now. You know, version 2, new and improved. So now I'm putting my actual domain name, which let's try version 1. Just I want to show you that it won't work. So this fails. I don't know why it's saying it's saying success. It may not be compatible with P error, but we do know that it returns what, 0 on error, which is, let me see. Did I miss the return value? Oh yeah, right here. Return 0 if the address is valid, or non-zero if it's valid, 0 if not. Yeah, see, I don't think this actually plays well with the P error, the error no, which is why it's a success, but we know it's actually a failure, so it won't actually connect to it. And if you would actually remove that check and just let it go through, 99% it would fail to connect, but it would be some kind of garbage data that would maybe convert to an actual, you know, long into a, you know, an actual IP address. Who knows, it could possibly work, but odds are it wouldn't. So now if we try our new one, we run the same command. This is version 2. It connects and tells us the port is open. And again, let's try, like, you know, 76, close. Let's try, like, let's try Google. Obviously port 80 should be open, and it is. I don't think Google has any other ports open. You know, you can go with CNN.com, port open. you know, my SSH server, port open, FTP, connection refused. So, you know, so you can see here, this works, but it's kind of tedious, you know, doing one at a time. So let's go for version 3 here. Whoops. Where we're going to actually make it kind of just loop through and scan a bunch of ports. So this will be the final one because it's getting pretty long on this video. But let's see what we can do here to actually make it kind of... Oh, I just dropped my microphone. That's good. See if I can make it so that it loops through and scans a bunch of ports for us. So that's not, and that's not actually going to be very hard. I'm just trying to set my microphone up here again. It's like almost ready to fall again. So we'll just come down here. I want to take out the port here. And let's see, we'll go down here. The address will stay constant, so we'll go here for ti equals 0, I less than. We'll check the first 1024 ports, which you have to be root to bind to. Go like that. Yeah, so we're checking just 0 to 120. Well, actually, 0 is not. So we're checking 1 to 1024, and in Linux, Unix world, I guess actually in Windows too, in order to actually bind a service to listen on a port between 1 and 1024, you have to have root privileges. So anything above 1024, you can be a standard user, but anything 1024 and below, it has to be a root. It has to at least have root privileges to start the program. So we're going to check those ports. You can check the whole list, the exhaustive list, 65,000 plus ports. But for this demonstration, we'll just check 1024. Actually, let's start it where... nah, that's good. So we're going to actually set the port in here. Oops. So we don't need AC to integer because it's already going to be an integer here. Oops. But we do still need to convert it to network byte order. And then we will run the connect. So remember, we've got to actually cast it to the generic type here. And then take that, put it up here. So again, if returns less than 0, it's not open. Else. We'll report that it's open. Don't need this. I think that will work. Oops, that's not good. So there. So now it should scan all the ports for us, although there is something else I've got to do really quickly. Right at the end of the loop, we gotta establish a new socket because we've already used this one. So we're gonna close it, and then we're gonna go sfd equals socket, AFINet, sock stream 0. So now, if we compile that, we get some errors. Return undeclared again. I called it return. Okay. Just go like this. Implicit declaration of close. Unix standard. Yes. Okay. So again, the header file for close is this. Going a little quicker here now because I want to finish this video. And let's try it again. So now we don't need the second argument because now we're doing a list of 1 to 1024 for ports. So let's just scan my web server. And that's not what we wanted. I equals 1, I less than 1024, I plus plus. Oh, so we can't return in here now because we want to keep scanning. So that was stupid of me. Take that out, take that out, take that out. So again, see what I did there is normally we were scanning one port, so we're just simply returning if it was not open. But in this case, we want to keep scanning other ports, so we don't return. We're just going to close the socket, reopen it, and scan a new port. And so here, I'm going to stop it. So here you can see it's scanning all the ports. I could have put the port number there too, but we know it's 1, 2, 3, 4, 5. This is 22 is open. You would have got down to 80. 80 would have been open, etc. So I mean that's how you write a super simple port scanner. Add a little bit of functionality to scan force 10 to 24. Port 1 to 1024. Super simple. This isn't I'm not really what you call skilled at this. I'm not even skilled at C. Obviously, you can see I stumble around a lot. Part of the unpolished nature of these videos is you kind of see exactly what you're going to go through when you actually code and learn and do this kind of stuff. So again, I hope it was beneficial to somebody. I know not many people actually really check the channel out. I mean, I feel like I'm talking to myself, but maybe one day someone will find this useful, and that's kind of the goal. And thanks for watching, and have a good day.